Okay, today we're going to learn something called Cramer's rule. Okay, you guys should be aware that there are several ways to solve a linear system. Okay, so the first couple ways you actually learned about in previous classes, those were graphing and you found intersection points, then substitution, where you solved for a variable and then you substituted back into another system or another equation. Elimination, where you used addition of the two equations to get rid of one variable temporarily. Okay, and then this year we learned about matrix equations using the inverse matrix. Okay, and now today we're going to learn something called Cramer's rule, which uses the determinant. Now, I always thought that Cramer's rule was really kind of cool. Um, it's very much step by step. There are, unfortunately, with it, there's a lot of room to make mistakes um, in basic arithmetic and not following the steps. So it's always good to kind of go and back solve and check your answer. Okay, now I think Cramer's rule is a bit much for a 2 by 2 matrix if you only have like an x and y variable. So I'm going to show you a 3 by 3. That's where I think you can kind of really appreciate Cramer's rule. 2 by 2, I would always use like graphing, substitution, or elimination. Okay. All right. So here's our first example. We have a 3 variable system. Okay. Our very first step is to write it as a matrix equation. So we have our coefficient matrix, our variable matrix, and then our constant. And I dropped a 2. Okay. So I just did that first step. Okay. Our second step is to find the determinant of our coefficient matrix. Okay. Now, I'm going to warn you, I'm going to try to do this all by hand except for the basic arithmetic because I don't trust myself to multiply. All right, here we go. So remember, when you find a determinant of a 3 by 3, you actually have to write the first 2 columns down twice. Okay, so I'm going to rewrite 4, 2, 5, -1, 2, and -2. Okay, so now we're going to do major diagonal and minor diagonals. So 4 times 2 times 6 is 48. -15, -4. Okay, so I'm going to get out my calculator to handle the arithmetic because you'll see if running Cramer's rule, I mean, it's not hard, but it is a little tedious, and you honestly don't want to make a mistake because it's kind of hard to find that mistake because there are a lot of steps. Okay, so remember when you do find the determinant, it is bottom minus top. We're going to call this determinant of A. Now we're going to hang on to that number. That number is super important because we're going to come back to it and use it about 3 times. Okay, now that number 55 also tells us that there is a solution to find. So at this point, if you found your determinant was 0, then you would know system has no solution or system has infinite solutions, and you would just kind of stop. Okay? All right. For our third step, okay, first what you're going to do is you're going to take your coefficient matrix and you're going to replace the first column with the constant column. Okay? So we're going to rewrite the coefficient matrix but we are going to replace the first column, or the x column, which just so happens to be the first column, with the constant column, or the constant matrix. Okay, so let's go ahead and do that. And there's another step that we have to do. Okay. So my first column becomes 12, 1, 22, and then -1, 2, -2. I get to keep my second column, and I get to keep my third column. Okay, so that first column gets replaced with that constant column. And remember, the constant column is what you're equal to, so 12, 1, and 22. Okay, now find the determinant of that matrix. Okay, so same process, rewrite, and then diagonals. Okay, we're going to go up. Okay, now we're going to call this new determinant, we're going to call it matrix X. Okay, remember it's bottom minus top. Okay, so now since you have that information, you can actually solve for X. So the determinant of X divided by your determinant of A, which is 110 divided by 55, that is your solution for your X variable. So your X is equal to 2. Okay, now to find Y and Z, you do the exact same thing, but you're going to replace the y column and the z column. So let's walk you through it. Okay. So to find okay. So put your x column back. Okay, there's our original x column. Now our y column will become that. And then our z column stays. And now we're going to find the determinant of that. Okay, so let's go ahead and find that determinant. And you can kind of begin to see, because there are so many steps and you're adding and you're multiplying and doing all that fun stuff, it's not hard work. But if you make a mistake, it's really hard to track. Okay, so the determinant of y, bottom minus top, negative 165. Okay, now to find y, you're going to take the determinant that you just found, divide it by the very first determinant. So negative 165 divided by 55, negative 3. Okay, so now we have x equals 2, y equals negative 3. Now if you wanted to, what you could do is you could solve the rest of it by substitution. Okay, but I'm going to go ahead and find z by using Cramer's rule. So again, we're going to do the same thing, except we're going to replace our z column with our constant column. Oops. Can't spell. Okay, here we go. So our x column and our y column come back. Our z column gets replaced. And now we're going to find the determinant of that. Okay, here we go. Uh-oh. Do you see what I did? I didn't replace my Z column. So we're going to have to start over a little bit. I forgot to replace my Z column with the constant column. That is one of the mistakes that you can make when you're distracted. Okay, let's start over. No, well, not too much over. You just need to fix that. We'll get rid of all these little X's. Like this. Okay, here we go. This should be a 12, a 1, and a 22. See, that's good because we caught that mistake really fast. Okay. All right, so write your first two columns again. See, it's very easy to make a mistake. So 4 times 2 times 22, 176. -5, -48, 123, 120, -8, -44. Okay, here we go. So the determinant of our Z matrix is 123 minus 68, 55. So the value of Z is the determinant of our Z matrix, determinant of our A matrix. Okay, so we've applied Cramer's rule a few times, and our solution is 2, -3, and 1. Now, you might argue that, Mrs. Harris, I can just pop this into a calculator, it'd be much simpler, but Cramer's rule is kind of good to know because it gives you a value for the determinant. Okay? All right, thank you for watching.